devices. So this is the construction of a MESFET. You know, you take a semi-insulating gallium arsenide, you fabricate, it's an N channel, okay? You fabricate two N plus regions, which is going to be your source and drain, and in the N channel you will be that is going to be your gate. So when you apply suitable voltage, you will be having the formation of the depletion region. L the channel length and D the channel width. This is going to be the symbol, and this is the symbol for gallium arsenide depletion MESFET. So when you are going to have a depletion, you are going to have a dark line. A thickened line you are going to draw for depletion MESFET, D MESFET. And the construction, first you have to have a conducting channel between the source and drain. So carrier flow is going to be from the source to the drain, which is going to be controlled by the Schottky metal gate, which is going to be the metal semiconductor junction, or you can call it as an ohmic contact. So you can vary the channel characteristics by applying the voltage. Okay, so by applying the voltage, the channel characteristics are going to change. Thereby, I'm going to vary the current between the source and the drain. So if I'm going to if I'm going to change the applied voltage, the channel width and height are going to change, which is in turn going to affect the current, which is going to be generated between the source and drain. The drain current is going to be affected by the applied voltage. So on the thin epitaxial layer of gallium arsenide, it uses active region. The active region will have very high resistivity, referred to as a semi-insulating substrate. Okay, on this substrate only, I am going to a thin layer of N-type gallium arsenide is grown to form the channel, and above the channel only you have your gate. So in a semi-insulating gallium arsenide, first you grow the N-type region, and this N-type region is going to be your channel. And above this channel, you will be fabricating a metal region, and that is going to be taken out as gate terminal G. On either side, I am going to diffuse two heavily doped N plus region. I am going to have a metal layer, and above them, it is going to be fabricated as source and drain. So gate is sitting on top of N region, normal N region, whereas source and drain, they are sitting on tops of heavily doped N region. You call it as N plus region. The photolithography, I have to dug out that regions for source and drain, and I'm going to form a Schottky barrier gate there also. You can see from the diagram, this region inside the N plus have to be taken out, and you have to implant N region, and you have to implant N plus region. Okay, that is done by photolithography. So you're going to apply a mask on the everywhere except these two regions. So you will be applying mask everywhere except these two regions, and by ion implantation, you are going to make this region from N into N plus. Okay, it is going to be an N plus heavily doped region. So this channel can be depleted into a semi-insulating substrate by reverse biasing the Schottky barrier gate. So whenever I'm going to apply the voltage, the channel conductance is modulated, the channel properties are changed, and the depletion region is formed under the metal by applying a reverse bias gate to the source voltage VGS. So you know that whenever you are going to apply a negative voltage to gate, it is going to be, the depletion region is going to be made wide and wide, which is going to change the thickness, length, and thickness of which is going to change the length and thickness of the channel. The schematic symbol for the N channel depletion MESFET is shown here. So this is the diagram for the notation for N channel MESFET. This is the notation for N channel MESFET. So due to the presence of metal semiconductor junction, these devices are called as MESFET, metal semiconductor field effect transistors, because of presence of metal semiconductor junction in all the three regions, gate, source, and drain. That is why you don't call it as JFET or MOSFET, you call it as MESFET, metal semiconductor field effect